Can you explain now, Husheng, why low pH is important for foliar products?
Well, there are two aspects to low pH product to be superior to any higher pH or alkaline pH. One is that the hydrogen ion, which is abundant in a low pH product, will practically bind with the negative charges of the cell wall. And if you look at the plant structure or cell wall structure, you will see that nutrients that are applied to the leaf, or for that matter come from the root into the leaf free space, need to pass that free space in order to move around and get finally into the cell. The negative charges practically come from products of cell wall structure, which is referred to as polysaccharides, galacturonic acid, and so on. So there are acid residues with negative charge.
Okay.
And they start to bind with those cations. Therefore, if I'm applying zinc, and rather than zinc going quickly into the cell, will be spent to neutralize those charges. Whereas if I have an acid pH or acid foliar product, it will neutralize those negative charges. In other words, forget about those interferences of charge and fixation of those elements in the free space. Free space is outside the cell.
Okay.
And therefore the entry into the cell will be very quickly achieved.
So it is important for rapid uptake of nutrient, is that?
That is right, yes.
Okay.
It's important for rapid uptake into actual cell passing plasma membrane. Now, the other side of it is that the other side of benefits of low pH is that hydrogen ion is actually a proton bound with sucrose, sugars, disaccharides, and then moves into the phloem tissue. Now that naturally happens by expenditure of energy from the leaf cells, that they extrude hydrogen ion and then they take the sucrose and hydrogen ion together. So if I'm applying hydrogen ion in a fertilizer, I'm helping the energy saving in the plant and assisting with more sugar loading into the phloem. And of course, if I load more sugar into the phloem, then photosynthesis goes at a greater pace, and more nutrients or more carbohydrates, if you like, get into the other organs, including the root system.
So any product that is based around the technology of low pH is really a superior product, a superior crop nutrition product for the plant.
For the foliar space.
For the foliar aspects.
For the foliar space. Now the reason is that the root has got a different system.
Okay.
Root actually works best in a pH of, let's say, around 5. Now leaf tissue can benefit from that low pH, whereas low pH in the root system can damage the cell membrane. Whereas low pH in the leaf free space creates a potential for sucrose uptake, so the hydrogen ion is quickly consumed. Whereas if I put a root system in a low pH, the low pH actually stops certain reactions like proton extrusion, which is needed to take the cations. In the leaf system, we continuously consume that low pH to make more sugars.
Okay, so how do you keep that balance? How does that balance between the root system and the leaf system of nutrient intake? How's that created?
Well, the balance is really, if you look at the mineral nutrition stepwise from the root to the leaf free space and inside the leaf, you really pass through four steps.
Okay.
So it's not as simple as that to keep the balance with the pH. We are trying to have the optimum pH for the root. We are trying to have the low pH to benefit the photosynthesis in the leaf. And the reason that we can do it through the soil, and that's one reason we go for integrated fertilizer, because I cannot maintain low pH gradient in the leaf through the activity of the root system, because what comes up from the root system is normal pH. It's about pH 5, pH 6, just like soil solution under most conditions. So the application to the leaf of a low pH foliar is our opportunity to induce photosynthesis, to increase photosynthesis.
Very complex, but thank you for explaining that.